Hi, this is lesson 15 in the use of JASP and understanding statistics, and today we're talking about reliability. So to get started, let's open up a data set in JASP, go to Open, Data Library, and even though we're talking about reliability, we're not going to go down here to reliability, we're going to choose a data set from t-test. So go to t-test, and down here, there's a data set called kitchen rolls. So go ahead and open that up. Let me tell you a little bit about this data set. So there was some researchers who conducted a study to show that clockwise movements increase preference for novelty. So what they did was they had one group take a kitchen roll and churn it clockwise, and another group churn it counterclockwise. And they hypothesized that if you churn the kitchen roll clockwise while quickly jumping in to answer questions about openness to experience, that you would be more likely to show a preference for novelty or greater openness to experience. Here's examples of items from an openness to experience scale. Items like I have a vivid imagination. I often daydream about possibilities for the future. I am deeply motivated by art or work. I experience a wide range of emotions. I like to try new activities just for the experience, and so on. So those are items similar to the ones that they assessed. They used a measure of the NEO, which measures neuroticism, extroversion, and openness to experience, as well as a couple of other personality characteristics. And they obtained scores on 12 questions. If we go over here to the data, we see here's those questions, Q1 NEO, Q2, and then it goes all the way to Q12 NEO. And then over here, they've taken the average of those, and for some reason, they went ahead and subtracted 3 from that average. Each one of these scales, a range of responses going from 1 to 5, as in strongly disagree would be 1, strongly agree would be 5 for each one of the items. So the question is did this measure come out as a reliable measure? We're going to do that using the reliability module. So up here on top, go on over and find reliability. Remember, you might have to add it if you have not already added the reliability module. There are modules that you can click over here and then add. And we're going to click on unidimensional reliability. And what we're going to do is we're going to take items 1 through 12, and we're going to put it over here. And what has been assessed by JASP is what's called coefficient omega. It's also called McDonald's omega, since McDonald was the person that put forth this particular statistic. There is another measure of alpha, which has traditionally been much more widely used, and that's called coefficient alpha. Coefficient alpha is also called Cronbach's alpha, since Cronbach is the one that devised that particular measure. So our measure of coefficient omega comes out as 0.677. Our measure of coefficient alpha comes out as 0.648. These are a bit subpar. Here are rules of thumb for assessing the reliability of a measure. They tend to be the same for both Cronbach's alpha and McDonald's omega. That is, if they're 0.70 or better, then they're acceptable. 0.8 and 0 and better is considered good, and 0.90 and better is considered excellent. Of these two measures, coefficients omega is considered to be the more accurate one, but many times these don't differ a lot. Coefficients alpha can be very close to coefficients omega if the assumptions for coefficients alpha is met. The main assumption that Cronbach's alpha makes is that all items contribute equally to defining the construct, in this case, openness to experience. And if that is not met, coefficient omega tends to be the better measure. Let's take a bit of a deeper dive into how to look at the reliability of our measure and what in practice we might want to do, especially if our estimates are not meeting that 0.70 threshold. So over here, notice that you can click on coefficient alpha if item dropped. Let's also click on item rest correlation. Item rest correlation is the correlation of one particular item to the rest of the scale. So here, when we look at the NEO question 1, it has a correlation of 0.542 to the average of the rest of the scale. That's good. It has a strong correlation with the rest of the scale. That is basically what we want. We want items that correlate in the 0.3 to 0.7 range primarily. And so that works for the first three. Item 4, not so good. Item 6, not so good. Item 7, really poor. It doesn't correlate hardly at all with the rest of the scale. Neither does item 9, and neither does item 11. So there's 3 items that I see there that are doing pretty poorly because those items don't correlate with the rest of the scale. When they don't correlate with the rest of the scale, when we look over here at coefficient omega if item is dropped, we notice that the coefficient omega is predicted to go up. So if you drop item 11, it should go up from its 0.677 to 0.680. Item 9 from 0.677 to 0.698. Item 7 from 0.677 to 0.694. And so here it's really easy. One nice thing about JASP is the ease in which you can go ahead and exclude items. All 3 of those items I would judge to be pretty poor items. So I would take out item 7, item 9, and item 11 if I was building a scale. And you notice that now coefficient omega is above 0.7, so is coefficient alpha. You can also get that same index for coefficient alpha if you click this. But what happens with coefficient omega is going to be pretty redundant with what's happening with coefficient alpha. Pick one to make your decisions. You don't need to use both. You can also get the split half coefficient here. The split half coefficient is actually coming in a bit higher than coefficients omega and coefficient alpha. Interestingly, coefficient alpha is designed to be the average of all split half correlations. That is, if you take 1/2 of the scale, say I took, for example, items 1, 2, 3, 4, and 5 and averaged those together, and then items 6, 8, 10, and 12 and averaged all of those together, then correlated that 1/2 average with the other average with the average of the other half, and you did that repeatedly for all possible averages. That's what coefficient alpha was designed to mimic, but it only does that when the assumptions are met that each item contributes equally. That's not happening here. It turns out that the split half reliability is actually coming out a little bit better. Now, what would you end up doing in terms of making decisions in this case? Well, this is an unusual experiment where people are trying to reply to questions while they're doing kind of a weird task. And so I probably wouldn't throw out any of the items, even though the reliability is a bit low. I would probably stick with the original scale because it's a well-validated scale. And I believe you'll find that under normal conditions, the reliability of that scale is going to be sufficiently high. I might go ahead and first run the analysis with all the items and then just double check that I don't have some fluke as a function of lack of reliability by constructing another average where I've tossed out the items that are making the scale unreliable, as I've done here. Most probably, I would just stick with the measure and report that the reliability goes down under these conditions of doing the task. And that's an introduction to reliability.